Hi class, this is number 2 on 7.3. It says, according to a study, the length of pregnancy for a randomly selected female has an unknown distribution with a mean of 266 days and a standard deviation of 14.4 days. Let X be the length of a pregnancy for a randomly selected female and let X bar be the average length of a pregnancy for the average random sample of size 33. Describe the probability distribution of X and the state of its parameters mu and sigma. So because this is not normally distributed, we don't know that it's normally distributed. We're going to have to say that it's unknown. And a lot of times when we don't know the original distribution, we just use the binomial distribution. If it appears to be like it's independent trials. All right. So, and then although we don't know the distribution, they can still say the mean is 266 and standard deviation is despite, no matter what the distribution is, we can still say the standard deviation is 14.4 and the mean is so and so. Now this is important to this next part. Because we don't know the distribution, we can't use the normal CDF function. Normal CDF function finds the area under the normal curve if the distribution is normally distributed. In this case, it's not. So we really don't have any way of finding the answer to part 1. So we're just going to say that it doesn't exist, that it can't be found. If we don't know that the original distribution is normally distributed, there's nothing we can do to find the probability. Okay. In certain cases, you'll find in some problems, and they'll let you know, like, oh, you can use the binomial distribution in this place, but they'll let you know in those problems. Okay. Use the central limiting theorem. So in this situation, we look and we notice that the sample size is greater than 30. So no matter what the original distribution is, we do know that the sampling distribution is normally distributed. So we can go ahead and find and calculate the probability for about the mean of a sample having a certain quality. The original population is no, okay, that's not true. The original population is not normally distributed. The sample size is large, although the distribution of the original population is unknown. That is true. That's the one we want here. Okay, then to describe the probability distribution of the X bar and state the mean and standard deviation, well, it's normally distributed, so N, because the sample size is large. And then the mean is the same as the mean of the original distribution. So this 266 is going to stay the same here as 266. Then this is the big formula that we have to remember, and that is that the sampling the standard deviation of the sampling distribution is equal to the original standard deviation divided by the square root of n, right? And n in the original distribution, if we just like go up a little bit, we'll see that it's 14.4, the original standard deviation, and then the mean. I'm sorry, the n is always a number in our sample, and they say a sample size of 33. So that is the square root of 33, and that's not going to be a pretty number. I'll tell you right now, because like whenever you have a number under the square root that's not a perfect square, like 25 or 49, or then it's going to be an everlasting decimal number. So let's go ahead and put that into class calc, and we're going to get that number, what they think they said, to 1 decimal place. So let's find that number by putting it into class calc. So 14.4, and I say divided by, and I put SQR, and then as soon as I press T, then it just does a square root for me, and then 33. And then there's my so to one decimal place is 2.5. However, when we go to do prime probability, I'm not going to use 2.5. I'm going to use that whole decimal, and I'm actually going to use that whole expression, 14.4 over square root of 33, just to be more accurate with our answer there. So for this answer, though, it's 2.5 that we want. .5. And then now find the probability that the average length, so it's the average, talking about an average length of a sample of 33. So this is a sampling distribution, which we do know this is normally distributed because it thanks to the central limiting theorem. We don't know anything about the original population, and we can't calculate anything at that, but we can calculate the average information about a sample of 33. So find the probability of the average length of a pregnancy for a average length of a pregnancy for a sample of 33 is more than 271 days. Well, the mean here, the peak is at 266. So that helps me determine where the 271 would be located. So like, that was really good. I would draw in where one standard deviation is, or halfway down this hill here, but I'm just going to say it's just somewhere to the right here. And they said that it's more than 271. So that where the numbers more than 271, they're to the right. And so if I'm going to get this problem, I need to find the area under this curve. That is the probability that like a sample of 33 will come back with an average of 271 days or more. That probability is this area under the curve. And now my job is just describing to the calculator, this area, and I have to tell it where the shading starts. And I always go from left to right, where it starts and where it stops, or where it's being cut off, like bounded by. So I noticed that, look, it's being bounded by 271 on the bottom, and it's actually including 271. So we should actually make a square bracket there, 271. It doesn't matter too much to us. And it's stopping. See, it's going on forever as we move further to the right. So it's positive infinity. So this is my lower bound, and that's my upper bound. But of course, the TI-84 calculator would not understand positive infinity. So you would have to put it normal CDF, because this is normally distributed, because thanks to the central limiting theorem. This is your lower bound is 271. The upper bound, I'm going to put positive 1 because it's positive infinity. E to the negative 9, e to the 99. Sorry, not the negative 99, e to the positive 99. Then I'm going to put in the mean, which is 266. And then I'm going to purposely put the whole formula. And I think the calculator is pretty okay with you doing this. Like I put the whole formula, like the 14.4 divided by the square root of 33. If you can't put that full formula in there, then I would just keep it accurate to at least 4 decimal places. That way our probability is accurate here in this final answer. But let's see. So this is how you would do it on the TI-84. Let me show you how you would do it on a class calc. So I would do stats, distance plot, normal CDF, and then I put my mean 266. I put my standard deviation. I'm going to put the 14.4 divided by, and then I'm going to put SQRT 33. I believe that was the mean standard deviation. Then I choose CDF because it's over region, and then see, ours is from 271 to positive infinity. So this lower bound is 271, and then it goes, the higher upper bound is positive infinity. So it's telling me that the probability is 0.0230. And I don't know how many decimal places they wanted us to, but 0.023. So let's go back and see how. So that's exactly at 0.02 and 0.02. What did we get? 0.0230. Let's see if they would take that. 0.0230. Let's see if they would allow that. And if they don't like this answer, it's probably because they want us to input this 2.5 and I'm being overly accurate. So like that might be the case. Yeah, they actually don't like my answers because I was overly accurate and I'm not using the standard deviation that they have stated here above, which kind of makes sense, I guess. Like they want us to use their standard deviation that they have already, I guess. Okay, so let's change it. I'm being overly accurate by like keeping this whole formula in there, and they just kind of wanted us to, I believe, to keep the 2.5 that we stated above, so 2.5. And I think it didn't, I think it wants me to do it in this box, 2.5. Okay, and there's the 0.0228, exactly the answer that they wanted. All right, so that's just a kind of a little side note here. If they ask you to previously, like in the problem, round off the standard deviation, then you probably want to use that rounded version of the standard deviation when it comes to the final answer here. Although typically if they had not asked for that, if they didn't ask for this step, I would say if they didn't ask for the standard deviation up here and ask you to round it off, then I probably would say like I keep it everything as accurate as possible. But because they asked us to round that off, that's probably why they're wanting us to use that rounded version of the standard deviation. All right, but if you feel like you're working on these problems, I feel like I got that right and I should have gotten that right, and then just email me about it, because I feel like they should have accepted, I had a more accurate answer, and they should have accepted my answer as well. But that's okay. All right. I'll have to message the owner about this problem so that they can kind of fix that. But yeah, just email me if you think that you're mismarked on a problem like this, okay? All right, have a great day, everyone. Bye.